Cyber Operations and Risk Management Briefing by January Fubara for Group 1, including Derek Grice, Moshe Golian, and Sharon Joyner, University of Maryland Global Campus, and Capstone in Cybersecurity by Dr. Marian Learberger. Abstract. Cyber operations and risk management involves making sure that all organizations' software and hardware manufacture and installation throughout the supply chain are free of vulnerabilities. Employees are properly trained to use complex alphanumeric passwords. There are regular updates and patches of all systems, and there are a dedicated cybersecurity team there to ensure that in the event of an attack, they will be able to mitigate, stop, and keep the company functioning properly. In a New York Times article written by Scolino in 1988, the United States government mistakenly trusted and allowed Russian government to provide both the material and labor in building the U.S. Embassy in Moscow. The 8-story American Embassy in Moscow stands useless, infested with spying systems planted by Soviet construction workers, a stark monument to one of the most embarrassing failures of American diplomacy and intelligence in decades. Over the years, the United States has spent over $23 million on the building, but more than twice that amount in an attempt to figure out how the Soviets used eavesdropping devices to transform it into a giant antenna capable of transmitting written and verbal communications to the outside world. Disclosures of the electronic penetration of the new embassy followed in April 1987, and for the first time it became publicly known that the Soviets had installed a wide variety of intelligence gathering devices whose technology was not understood by the United States. The building was eventually razed. In cyber operations and risk management, the company must ensure that everything that is being used by the organization is safe from any vulnerability. The company must, in their dealings with vendors, include language in their contract that every component provided by the vendor is risk-free, and that the vendor will bear the cost of any vulnerability attack arising from their inventory. In the case of the United States Embassy, the United States relied on an untrusted vendor and wasted several millions of dollars on a building that was useless to the national security. Software assurance needs and expectations. Software assurance encompasses development and implementation of methods and processes for ensuring that software functions are intended while mitigating the risk of vulnerabilities, malicious code, or defects that could bring harm to the end user. The main objective of software assurance is to ensure that the processes, procedures, and products used to produce and sustain the software conform to all requirements and standards specified to govern those processes, procedures, and products. Information assurance has become an important component of data security, as business transactions and processes consistently rely on digital handling practices. Software assurance seeks to reduce or remove vulnerabilities to increase confidence that software can be used securely and effectively. With the rapid technological advances that have made computers a commodity and specialized software the norm, there is an increasing need to ensure that software performs as expected and is not violated with malicious code or unauthorized actions. It involves every element that has been potential to touch the software, and to be effective must take a holistic approach to both understanding the environment in which the software is developed and used, as well as the requirements for the software performance. Software assurance objectives must be developed and assessed at all levels as they determine and organizations' exposure to risk. Some examples of software assurance objectives: reducing the potential exposure of or release of personal identifiable information during disaster recovery, always sustaining inter-office connectivity and access to data, constraining costs while maintaining schedules. The software developers and security teams can use objectives that these to drive the security requirement definition. They will set up feedback loops as well for assessment and reassessment of documented requirements and perhaps to modify objectives as needed changes and for consistency. Key attributes of current software development cycle. These include planning, creating, developing, testing, and deploying. The new 7 phases of SDLC include planning, analysis, design, development, testing, implementation, and maintenance. Software development lifecycle is the application of standard business practices to building software applications. It is typically divided into 6 to 8 steps: planning, requirements, design, build, document, test, deploy, and maintain. SDLC, or Software Development Lifecycle, is a process that produces software with highest quality and lowest cost in the shortest possible time. SDLC provides a well-structured flow of phases that help an organization quickly produce high-quality software which is well-tested and ready for production use. Cyber supply chain risks may include insertion of counterfeit, unauthorized production, tampering and theft, insertion of malicious software and hardware, as well as poor manufacturing and development practices in cyber supply chain. Key attributes of current software development continue. Global trade wars and political upheavals such as Brexit, raw material shortages, safety records, climate change risks, tougher environmental regulations, economic uncertainty, cargo theft, container ship fires, the current COVID-19 lockdowns in China that is affecting the supply of microchips used in the manufacture of everything from toys to vehicles and automobiles, since most chips are made in China. Known supply chain risks. In today's business environment, the supply chain management, that is, the management of goods and services moving from raw materials from different suppliers in different countries, possibly different continents, to the work-in-process inventory and eventual manufacture of products can be a daunting task for any organization to manage. Within this long chain, there is ample room for cyber criminals to use one of these links to introduce malware or worms that will eventually end the company's target computer network. This type of attack targets entities by aiming at one of the vendors with weak security measures in its protocol within the supply chain. As the weak link includes the virus in the production line, it will eventually end up at the targeted company, which will unknowingly install the Trojanized equipment or software into its network. The hacker or criminal will then wait at their convenience to start gathering information they need from unsuspecting companies. This type of attack is always difficult to defend against. Known supply chain risks continue. The best defense against such an attack is to have coordinated security protocols all along the supply chain to make sure everything moving through the chain is clean and free of any virus. The ultimate goal of any risk management process is to mitigate the risk by identifying, eliminating, or at least reducing the factors that will produce any vulnerability. Some of the factors that affect the risk element are the countries where any of the partners in the supply chain is located. Suppliers and distributors within the chain can also pose a risk to the chain. The virus can be introduced at any step in the process of manufacturing the product. Therefore, from shipment to delivery, and the physical security of all the products, even in the warehouses, must be monitored at all times. In short, every step in the manufacturing process must be monitored, including the very staff who make deliveries must be screened for anyone with questionable contact. Threat modeling principles. Ideally, software should be tested and all errors eliminated before it is deployed. However, exhaustive testing of software is impractical and not cost-effective, so risk-based testing can be employed. Risk-based testing identifies and prioritizes risk based on levels of threat, impact, and mitigating costs. Risk-based testing thoroughly test the areas of software that are the highest risk, thus ensuring that the most threatened areas of the software are the most secure. Developers, testers, and project managers are required to identify the parts of the software that may appeal to attackers, break down the software to understand exactly how separate components work, rank the risk, and develop strategies for remediation if the risk is ever exploited. Since the risks are prioritized based on its severity and importance, the most important risks with the highest impact can be reduced or resolved first. In conclusion, the rise of phishing attacks poses a great threat to all organizations. It is therefore important that all companies know how to spot some of the most common phishing scams if they have to protect their company's valuable sensitive information. In recent years, hackers are targeting the brand of major corporations. Criminals falsely use the logo of these companies, exploiting the trust established by these companies to send spoofed emails to customers. One successful attack can cause irreparable damage to the company's brand and the goodwill the company has built over the years. The company can lose huge sums of money to legal fines from local, state, and federal officials if it is found to have exposed customers' credit card information due to hacking by criminals. The supply chain, including vendors' components, must be vetted for safety, as any weak link in the chain could break it. The end.